Okay, class, so we have already talked about what a composite is, what a composite is made of, some uses for composites, and we just talked about examples of composites. But today we're going to discuss how making a composite section. A composite includes really two types of materials, and the matrix surrounds and binds together a cluster of fibers or the reinforcement of the composite. So you don't need to write this. There's only a little bit of space for you to put in your notes, but what I have is I separated the steps in this PowerPoint, and all you have to write or type is the stuff that is underlined. So I kind of kept it to as much or as little as I could so you guys could fit it into your notes. So this is what was in the notes. It says, over recent decades, many new composites have been developed, some with very valuable properties, and there are steps to this process of making a composite. So the steps overall that we'll be talking about are choosing a material for the matrix, choosing a material for the reinforcement, and then choosing a manufacturing process. So we're going to go over each step separate and kind of talk about what are the pros of picking a certain matrix or reinforcement and different manufacturing processes that can be used to make a composite. So the overall process of making a composite really is done in a certain way. So by carefully completing the three main steps that we just went out, or I briefly just went over, engineers can tailor the properties of each material to meet specific requirements. So they choose these things, or the reinforcement and the matrix, with thoughts of the overall whole product in mind. So, for example, engineers will select properties such as resistant to heat, chemicals, and weathering by choosing an appropriate matrix material that has those properties. So, the first step to this process is really choosing a material for the matrix first. Many modern composites use the thermoplastics or thermosetting plastics due to the durability and ability to survive high temps. So we already talked about thermoplastic composites. So a lot of engineers will use those thermoplastic materials as the matrix. And they're good. And I just put those pros underneath. You do not need to write those in your notes. The pros for using this type of matrix will be to that they don't become soft under high temperatures. They're resistant to wear and attack by chemicals, making them very durable. And even when they're exposed to extreme environments, they will stay as one and not be broken down. So the thermoplastic things that we've already talked about, the materials are durable, heat treatable, and also recyclable. So this is also why they have been put into composites nowadays. So this is why these materials are good for the matrix to start. So this is just step one. There are a couple other materials that are good, and I'm going to show you them on the next slide. The ceramics, carbon, and metals that we talked about in the last class are used as the matrix for some highly specialized purposes. So ceramics are good for items that are going to be exposed to high temperature because they won't be worn by those high temperatures. So an example of a ceramic matrix composite would be heat exchangers. Another good material for a matrix would be carbon. So we talked about some carbon composites, and they're used for products that are exposed to friction and wear, such as bearings and gears. So the second step for making a composite is choosing the material for the reinforcement. And like I said, in mind, those engineers will think of properties that they need for the overall composite and plan accordingly. So the most common fibers that are used in reinforcements are going to be glass and carbon. Glass fibers have been really used for a long time, and they're the most common reinforcement, but as many of these advanced composites have come about, like all the aerospace things that I made you watch videos on, those have introduced using carbon for a reinforcement. So carbon fibers are good because they're very light and much stronger than glass, because glass, can break very easily. But carbon is much more expensive than buying glass, and they have to think overall, is it better for it to be expensive or more durable? It depends on what engineer, what product you're looking for. So all of those will be in mind. So you figure out the matrix, you figure out the reinforcement, and then you have to put the two together. So the third step is really choosing the manufacturing process to put together the matrix and the reinforcement. This is done in either the first way with these 4 steps, or there's another process that I'm not going to make you need to know, but I think they did already mention it in a previous video that we talked about, or that I made you watch. So the third step is choosing the manufacturing process, and the most common method is this method that we're going to talk about, and it includes molds of products. So if you would want to make a helicopter wing composite, you would have a mold of that helicopter wing that you want. So the reinforcing material is first placed in that mold. So that second material that you put in, that carbon or that glass, is put in the mold. Then the semi-liquid matrix, so either the thermoplastics, the ceramics, the metal, that is going to be sprayed or pumped into the form of the object or into the mold. So then pressure may be applied to force out any air bubbles that may occur in that mold. So the mold is then heated to make the matrix set solid, because a lot of these composites aren't in a liquid state, or none of these materials that we talk about in material science are in a liquid state. We are usually dealing with solids, so they will heat this mold to make a composite that is solid. And the molding process is either completed by hands, or it can also be completed by a machine. And some of those machines could be robots, just like we talked about last class. So this is overall the most common process. On some really advanced industries, we now see a type of manufacturing process that is a little different, and it is called sandwiching. So many new types of composites are not made by the matrix and reinforcement method of putting them into a mold, but by laying down multiple layers of material and sandwiching them together. So that's why it's called the sandwiching method. It is used mostly for the aerospace industry, and it was shown cross sections of composites in that NASA video I made you watch. They kind of explained that they sandwich the materials together, and the different cross sectioning of, you could see the different materials stacked or the multiple layers on each other. So this is the second type, but you usually will see the first type. And the assignment for this class, you might want to use the first example because it's easier. It is easier to have more steps involved, and you can explain easier and better how to make a composite. So for your assignment for the rest of the class, and if you don't get it finished, it will be homework because I'm trying to get you guys to put a little bit more effort into not just a worksheet. Like this is kind of a prompt that you have to answer. So I want you to create written directions to create or to get someone to create a fiber reinforced composite of your choice. So you get to pick the fiber reinforced composite that there are multiple examples in your notes. And I want you to explain to someone how to make the composite that you decided. And you can explain through those steps we just talked about. So picking a matrix, a reinforcement, and then a molding process. So why did you pick that matrix for your composite? What good properties does it have? Why did you pick that reinforcement? Oh, you picked carbon because it is more durable instead of glass. That is all in the video. So you just have to tell me what you picked and then directions in full sentences. So you can do it like a dialogue or a step-by-step. Like first you do this, or second, then you do this, next you do this. Anything like that will work. Just this is worth 15 points, so you can take your time and draft up something and then copy it in, but I will know if you're using someone else's because it'll be word for word the same thing. So please work by yourself. Ask me any questions.